Hi guys, hope all of you are doing great. Today we are going to have a continuation of what we had discussed earlier on the electromagnetic radiation. In our earlier two videos, we had looked at the concept of electromagnetic radiations, description, and the form of electromagnetic radiation energy, and how we use a different formula in trying to describe the electromagnetic radiation energy. So in this case, we're going to look at the electromagnetic spectrum, and this basically consists of a range of frequencies in which electromagnetic radiations occur. So I'm just going to use this one as an initial because of space, but this one basically refers to the electromagnetic radiation. So in this case, basically for the spectrum, which refers to the range of frequencies in which electromagnetic spectrum occur, this is going to give us a clue on how we can be able to describe some of the spectrum that we're going to encounter in the subatomic levels as we advance. So from the electromagnetic spectrum, we are given different names which we use to describe various portions of the spectrum, which add a particular name. For instance, one of them is a radio wave or radio waves, and then we had looked at microwaves. This I'm saying in reference to one of our videos where we had an exclusive discussion on an electromagnetic spectrum. Therefore, this is a part of what we had encountered in our discussion of an electromagnetic spectrum. So in this case, we have infrared radiation, which is part of an electromagnetic spectrum. And then we have gamma rays, which sometimes are going to be given an initial for that Greek word, Greek letter gamma. And then we have the X-rays, which are going to be given as such. So therefore, in between this, or rather of all of these radiations, we're going to see that there is a portion that is referred to as the visible region. The visible region of the electromagnetic spectrum, which of course is going to be a point of interest for us, especially in this particular discussion. Now, of all these radiations, the human eye can only be able to visualize this particular region or range of electromagnetic spectrum that we refer to as a visible region. And this one has a characteristic way in which we can be able to refer it, since it lies within the frequency range of 400 to 700 nanometers. And therefore, this forms part of what we refer to as a visible region of that electromagnetic spectrum. Now, for instance, I can just give a relevant example of this. We have what we normally are conversant with. This is a rainbow whereby this sunlight rays are split using the droplets of water which are found in the atmosphere. And therefore, this is one of the examples of this particular frequency that we're going to use in describing some of the regions of interest for us, particularly the visible region of the electromagnetic spectrum. Now, this one generally is going to give us a clue on how we can be able to describe this subatomic spectrum, which I'm going to give using the illustration which is going to follow on the board. Now, whenever particles, or rather what we refer to as atoms, absorb energy, they get excited. So we're going to use this particular term, excited. And then we're going to see that this energy is in form of light radiations. And then later on, they are going to lose this energy. And we're going to see how we can graphically describe these two states of gaining or obtaining energy and then losing energy in this particular case. Now, we talked about the different levels of energy in an atom, and we're going to see that one, of course, in our topic of different quantum numbers that we're going to discuss, of course, in our other videos in this specific aspect of quantum mechanics. And we're going to see that when such a light, of course, which is obtained from this, I'm going to give this illustrative figure on the board to assist us understand this specific point. Now, suppose we assume that a particle like an atom will contain an energy. This particular case, I'm going to give this a graph of energy in this particular part. So as we go upwards, we're going to increase in energy. And let's say that an atom's particular energy. We talked about particular various forms of energy. Now, a particle that is of course, a static state possesses some kind of internal energy. So in this case, a particle like an atom has got an energy E0. And when it is excited, of course, it's going to absorb energy, as we have described in this particular case. And then its energy is going to move from a state of E0 to E1. And therefore, we describe this form as an excited state of that particular particle, in this case, an atom. So therefore, this energy is going to be in form of that particular this transition that I've given. So therefore, whenever this atom loses this energy, it's going to fall from the excited state, which is E1 to E0 at this particular point, and therefore it's going to emit or give away or lose that particular energy. So the transition in energy, as we're going to see from this, is the change in energy is going to be E1 minus E0. But there are various other ways that we're going to describe this particular kind of energy that we're going to experience in this particular case. So suppose I just give this one as this is light, which we have referred to as a photon. So therefore, it's going to lose this particular energy that it had absorbed earlier as a photon of light. So we can be able to describe this one using the various characteristics that we have mentioned in our previous videos. Now, we said that one of the characteristics of light is that it can be split. Suppose an incident ray of light falls on a prism like that. This is going to be split into various bands of this specific prism, which are going to occur in these specific lines. Now, in this case, when an atom absorbs energy and excited, it loses energy in the form of a photon. Now, suppose that photon of light is directed in this particular prism, then therefore it is going to be split into various bands that we're going to see in this case. Now, these are going to appear in form of a series of colors of discrete lines. Discrete lines which are roughly illustrated in this particular case. And these are going to be referred to as atomic emission spectrum. So these are going to be atomic emission spectrum. So this is one of the main objective of our discussion for today, trying to find a way in which we can be able to describe this atomic emission spectrum, or an experimental way in which we can be able to obtain the atomic emission spectrum. Now, this atomic emission spectrum is characteristic in a sense that it is unique to each atom. Therefore, giving us a clue on how we can be able to, of course, describe the various characteristics of atoms which have given this particular emission. Now, given that the excited atoms emit this light of a specific frequencies, as I've said that it's unique to each atom, then it must be true that certain characteristic energies are possible. So these certain characteristic energies, which of course we have given the concept of discrete lines, then therefore are going to be to give an implication that the electrons are restricted to certain energy levels. And these energy levels are going to be referred to as quantized energy levels. Now, in essence, this is giving us a characteristic of this energy of atoms, which of course are given as discrete lines, which are atomic emission, as given atomic emission spectrum. Now, this is going to shed a light for us in trying to figure out how this subatomic spectrum can open for us a window of describing various atoms and the various emissions that we can be able to obtain from various atoms that we're going to see. Now, this, of course, is going to open for us a window for discussion of subsequent topic on Bohr's model of a hydrogen atom, of course, which is going to consist of a series of emission lines that are going to be given specific names. And of course, this is going to assist us in trying to describe how we can be able to refer to different energy levels of these specific atoms. So the electromagnetic spectrum discussion, in conjunction with other videos that we have done on the energy and the description, therefore, it's going to have a compounding effect of us understanding these various aspects of a subatomic spectrum, or rather the behavior. And in our next video, we're going to see, of course, these various lines and some of the additional discussions which are going to assist us find a way of calculating the wavelengths of these various spectral lines that have given in this specific area. So catch us in our next videos. We're going to look at Bohr's model of the hydrogen atom, and we see some of the shortcomings of this particular model that was given by Niels Bohr on the concept of a subatomic aspect of the atom. So that is it for now, guys. Bye. Let's catch in our next video. God bless you.